So, good afternoon, everyone. Welcome to this talk about JetPack Compose. I've seen from the agenda and other conversations that in this community, you guys really like and love Android and JetPack Compose and all that. So, I think there will be people that will enjoy this talk. So, before we start, I want to understand the audience. So, who here is an Android developer? Okay, so 70%. Of those who have experience with Compose, okay. And of those that are not Android developers, who knows what Compose is? Have an idea? Okay, cool. All right, so let's just get started. Cool, so in the at the end of the talk, there will be some time for Q&A. So for those that don't have much experience with Compose, so you will have the chance to ask me anything, right? So this is me. My name is Eury Pérez. I'm a Dominican. I don't know if you know where that island is, but you may have heard of Punta Cana. So I'm from that island. But I live in Spain, northern Spain. And I'm an Android architect. I've been in the business of software development for 14 years, 13, 14 years, and on Android specifically for around 11 years. So yeah, I started programming in Eclipse. If you did that, I feel very sorry for you. I also organized a GDG in Santo Domingo, in the capital of my country. We organized also the DevFest. This year we took a break, but yeah, we'll be back. Also, I'm a Google developer expert in Android since 2021. So a couple of years, and also a follower of Jesus. So let's talk about Compose first. You saw from the title of the talk that I'm going to give you some tips and tricks and best practices and all that. But first, for those that are not familiar with Compose, I'll give a brief introduction to it, all right? So Compose is a declarative and reactive UI toolkit, right? So what does that mean? If you're familiar with other reactive and declarative toolkits like Flutter or React Native, you may be familiar with what I'm going to show you later. The user interface essentially is described, right? Different than on XML, which is not declarative. Here the UI is described and it reacts to changes in a state object, right? So we'll expand a little bit more on that later. So let's consider this simple data class. Very simple, only two properties. The name is user. It has a name and a headline, right? So, and we have this code. So it's very simple. It's just, as I said before, we describe the UI, right? So you see that there is a column. So the elements are stacked vertically. And we receive that data class as a parameter to our composable, right? So every composable is a component, a visual component, right? Just for reference. So here we have two text values stacked on top of each other, showing what we have inside of that data class, right? So, and the key here is that we accept the data as an argument. So Compose essentially with the declarative approach converts data to UI, right? And this is just how it looks. And then there is the second part I told you, we describe the UI, right? But it reacts to changes on it. So what happens if I change the value on the name? I put John Doe instead of my name. Yeah, it will react, it will be recomposing. And talking about recomposing, there is some concepts that we must know before going into the tips, right? And the first one is recomposition. We need to understand what that means. So first of all, composition, right, is when an element or a component or a composable, right, talking about the context of it, is first put into the UI, right? We call the screen that is being shown at any given time, we call it the composition, right? The composition is essentially the group of all the composables shown at any given time, right? So if that's the composition, what is recomposition? So recomposition is essentially the event that occurs when the UI is redrawn. So after the second time and on, that's called a recomposition when the state object has changed, right? So the only way to update the UI in Compose is by calling the composable functions again, right? There is no call like we used to do in XML, like that text equals to something. Like in Compose, we have the declarative approach, right? And when we change something in the state object, you need to call it again. That's what we basically call recomposing or recomposition. So essentially, coming back to our previous example, this is what happened here. So our UI was recomposed after the state object was changed. Now, another concept to understand first is stateful and stateless. I think on the last talk we saw something about this, so you may be familiar already. A stateful composable is essentially one that holds a composed state object, while a stateless one does not. Really simple. You hold a state object where you are stateful, you don't, you are stateless, right? So very simple. So in this case, it's a very, very common example, a counter, right? So in here, we are holding inside of the composable a state object, which we are naming count, right? We are building that using the mutable int state of helper function, right? So, and this is how it looks. Like every time I click on the button, you see that I'm increasing the integer state value, which I show inside of the bottom of the button text, right? So now the stateless one, as I said, it doesn't hold a state object, but the key here is that there's this concept in Compose called state hoisting, right? Where you lift the state to a pattern, right? To a parent. And when you do that on a composable, you need essentially two values. You can pass more values, but you need foundationally two values. One is your state. In this case, my state is the count, right? Is the data that I want to present. And if I have any action that the user can perform inside of that composable, I need to provide a lambda, in this case, to let the pattern know that that action happened, right? And the next concept is stability. Essentially, when the state object changes, Compose do its best to update only what actually changed, right? So in a complex screen, we can have dozens and dozens of composables, visual elements, and all that. So Compose don't want to recompose to call all those functions again, because that will hurt the performance really bad, right? So to achieve that, Compose relies on how stable the objects and properties are. But to be stable sounds subjective, right? But Compose defines a set of rules to determine if a piece of data is stable or not, right? So essentially, for a property to be stable, it needs to be immutable, right? So if it is immutable, the Compose compiler will determine or will decide, okay, this is stable, and I can for certain know that this property didn't change. So I'm going to give you some examples right after this. So you remember our simple data class that we had before with name and headline, right? But let's put it in context. You see that the name, in this case, is a var, right? You know that in Kotlin, for those that are not familiar with Kotlin, val are immutable. So once you set the value, you can't change it. But var, with R, you can change the value after it was set, right? And as many times as you want. So since var is unstable because it is mutable, indeed, then the data class is also flagged as unstable, right? So making this state, bad for performance. It has some exceptions, but in this case, bad for performance, because if I change one value, the whole thing is recomposed, right? Because compose doesn't have a way to know, But let's see. Now we have the interest. We added another thing, right? And so sorry, I forgot. Imagine that here, this is val, right? I forgot to change it. But now we have two vals, right? Three vals and a list. So what would you think it will work? If you're familiar with stability, you know that this class will still be unstable. And you may wonder why, because the list is an immutable list, right? But what happens? Wait, what? So you just said that if it's immutable, it's gonna be stable. So what happens? Okay, so let's go step by step. So calling immutable collections like list, set, and others are inherently unstable, right? But why? Because, this goes against what I said before. I will describe it with an example. Let's take this code here, really simple. I have a foo function. It builds a mutable list, right, with mutable list of. And I have this bar function that accepts an immutable list. Same here, seeing this is immutable, but this is mutable, right? So this is possible. Like if I build it as a mutable list, right, it was downcasted to an immutable one, I can cast it back to a mutable one. So that's why the lists, the collections that are immutable are inherently unstable. There are a couple of ways to fix it. I'm going to talk about some of them later, but one of them is a library from JetBrains about immutable collections. They have like a immutable list, immutable, and those kind of things. So you can, rest assured that Compose won't flag your state object as unstable because of this reason. All right, so let's see stability in action now. So you remember our simple code that we built before, right? So I changed the name, you remember that. So only that text composable holding the name will change, right? The one with the headline is not going to change because Compose knows for certain that that value didn't change because the class is actually stable, right? Okay, now knowing these foundational concepts, let's go over 10 tips, some of them simple, some of them a little bit more advanced about, to make your Compose code a little better. So the first one is composables should only do one thing. This looks very trivial, but I have found many cases in which people do too many things in a single composable. People used to make huge composables, and composables are not meant to be like that. Like composables are meant to be like atomically reusable small pieces of UI, right? So you can take always, this is what I do to determine how to design my own composables. I see how the Compose team designed their composables, right? How is the built-in button designed? How is the column designed? And then I start to see the best practices and all that they use, right? So I see that if they build a button composable, it just show a button. It doesn't do anything else, right? So that's what we should do. And one thing that you can use to actually maybe be aware that maybe you are doing too many things in that composable is the amount of arguments. If you are passing too many arguments that are not related to each other especially, you may be doing more work than is expected on that single composable. So let's go back to a user class, right? Let's go back to the interests, right? So you remember, let me go back a little bit. So we added the interest, right, which is a set of a string, but we only using the name and headline on the user title composable, right? Before, we used to pass the whole object because we were using all the properties inside of that object, right? But now we added a third property that we are not using in this composable. So it's better to only pass what the composable needs, right? To avoid also issues with recomposition and also to keep the thing clearer, like the code is clearer, express itself, it's better. So this is the first tip, right? Second one, avoid calculations in the composables. You can use remember when you really need to. Okay, so composables, you see in the talk that came before me, composables can be called as frequent as in every frame for animations, for example, right? So to go from color A to color B, there is a number of colors in between that the composable need to update, right? Because it needs to go smoothly, right? So to do that, remember what I said before. What is the only way to update a composable? Who remembers? Calling the function again or recomposing. So compose will call that function many times when we are animating to reflect all the changes of that animation, right? So it can be called really frequently. So I'm going to talk about two approaches here. There can be more, but I'm going to talk about these two. The first one is deferring the calculations to the view model. So imagine this. We have this view state data class. We have a product list, and we have a credit balance, right? In our composable, we are making a mistake because we are calculating like is affordable. And you can say, so this is a very simple comparison, like just less than. I mean, no matter how simple the comparison looks, remember that that composable can be calling multiple times per second. You know what I mean? And then this is not the only thing happening in your screen. So in your screen, there are multiple things happening. And if you like leave things slide, you know, you will end up with performance issues. So essentially, we can instead like defer that to the view model. If you're using a clean architecture, you can, in your use case, class or business logic, you can map that product and add that calculated property in that moment. So also another advantage is that you can move that off the main thread, right? You can do that mapping on the default dispatcher, for example, and that won't be causing any performance issues, right? So there are some situations in which we need to do whatever comparison or calculation in the composable. For example, we don't have access to the colors in the view model, right? So if we want to change between one color or the other, we need to do it in the composable. So to avoid this condition to happen, and this is very simple, but we can have a when, right? With multiple, and then also checking for types. You know that when you check for a type, is not a trivial operation. It's quite expensive. So when you do that, when you need to do that, right? You need to use remember, right? So remember essentially sets the value every time the key changes, right? So here that I'm passing here, this is the key. So every time is affordable changes, remember we'll call the function, the code that is inside, and every subsequent time, right? If is affordable is the same value, it will just return what it has already calculated, right? So this is very important to know. And yeah, the key, I mentioned that. Third tip, make sure your composables and state classes are stable, right? So we don't need to give any examples here. We already talked about this. But I want to suggest you to understand other ways the composables and classes are flagged by the compose compiler, like restartable, immutable, or skippable. It's very important that you guys go there to the documentation and read and know what every of these things mean. And two tips, run the compose compiler metrics. There is a command you can run that will give you like a report, right, of all your composables and all your data classes that are used on composables, right? So when you run that, you can know, you maybe think your composables are stable, but maybe they are not. And this report will let you know that. And also, since very recently, the compose team launched the strong skipping mode. So this helps enforcing a little bit more of the stability. So you can also read about that. The fourth tip is create a stateful and stateless overload of your screen composables, right? Let's see. So your screen composable most likely looks like this, right? Profile screen, for example, you have a view model in it, in the arguments or not, or inside or whatever. But to preview this composable, we will need to provide an instance to those dependencies. Like we need to instance the composable itself, right? To call, sorry, the composable itself. So this will most likely cause an error. If you go to the documentation of previews, you will see that the previews have has some limitations, like with view models, with some system classes, with some context, and all that the previews can't supply, right? So how we fix that? Yeah, also providing the data we want through the view model could be a complex task, because we could be collecting a flow, and all that can be very messy. So to solve this, create a stateless screen composable function. Essentially, you can create the stateless one, which will take the data, right, instead of the view model, and then in your stateful one, you can collect the flow and just pass it to your stateless one, right? And now you can just preview your screen composable and just pass the data you need to. Fifth tip, enforce the unidirectional data flow pattern with the MVI. So this is, I took this from the Android documentation. A unidirectional data flow, or UDF, is a design pattern where a state flows down and events flow up, right? So what does it mean? Here's a little graphic. Visually, it's always easier to understand. So here are our composables, or the composition. So essentially, the state or the data flows down, like the state holder, for example, the view model, will send the state to our UI, while the UI will send events to the state holder, right? For example, the UI will let the state holder know when someone clicked on that button, right? So the state holder can decide what to do, right? Okay, someone clicked the like button. Okay, I call the API, do whatever I need to do, right? So MVI is an architectural pattern that helps enforcing the UDF pattern. And MVI stands for Model View Intent, right? And what does this even mean? Model is the composed state, right? We already saw what a state object looks like. This includes the side effect, and this is a very large ongoing conversation and discussion that I will, so this involved people from JetBrains and Google, because the calling flows, people usually use channels for events or for effects or shared flows, but there are limitations. So I will maybe briefly talk about that and why I decided to follow Google recommendation, which is to include the effects inside the state. Then the V is for view is the composables, right? And then the intent, right, are, as I explained, UI events that trigger functions calls in the view model, right? This one in the code, I call it events to remove the ambiguity with the Android intent. You know that in Android, intents are a specific class that we use for specific things. So I call it events to avoid confusions there. Now, let's see how I can express that in Android, right? So first, a state is a data class, as you saw before, that holds the screen data. The events are the actions originated in the view that trigger a call to the view model. We can use a CL interface or CL class. I will show an example later. And the effects, right, are side effects that the view model send to the view. For example, showing an error snack bar, navigate, or do anything that is not related to drawing the UI, right? Which is something external. So here is how we can represent a data a view state, right? So a normal data class, you put there all your information. Then the effects, as I said, we can use a CL interface. We can create the effects. We can use data class or data object if we don't need any parameter. And lastly, the view events. So these, remember, that are the events that the UI sends to the view model. So here we have two possible events. We are using as an example a news list, news app, right? So the user can like any new or can reload the news. Imagine that they pull to refresh, or they just failed and we added a retry button. They can reload it. And let's see how we can use all these three classes or interfaces inside our view model. So we first need to add the view state flows, then add the view effect flows, add the consume effect, and then I will let you know what is that for, and add the process event function, right? So first of all, we will add our view state flows, which will be just a mutable state flow. We set the initial value of the view state. In this case, I'm not setting any values here because I usually do default values in the class, right? And then we use a backing property, right, to hide the mutable one. But it is very, very important. I have seen this issue before. People usually add the type here, right, like a state flow, and then do equal underscore view state flow. But you know what happens if you do that? The same that happens with the mutable list issue that I showed you before. Outside of the class, it can be casted to mutable state flow. So the as a state flow function that Android provides, or the calling provides, actually hides the mutable state flow. So prefer this instead. So this is the first thing. Second one, we will like expose a view effect flow, right? So as I told you before, the proposed approach by Google is to have the effect inside of the state class, right? So this is what I'm having here, but I'm exposing the effect as a separate flow by using the flow operators. So essentially, I'm taking the view state flow right here, and every time a state flow is updated, right, I will map it, right, and I'm only interested in the effect property, right? So I'm mapping that, I'm taking only the effects that are not null, right? And then I distinct it until changed, and all the upstream operations, let's say distinct until changed and map not null, will happen in the default dispatcher. This is not a best practice. This is for simplicity. Dispatcher should be injected, but just for simplicity, let's do it like that. And then the consume effect is to restart the effect to null, right? So let me briefly describe why we end up with this approach, right? With live data, this was so easy with the single live data that we implementation that we had and all that. But what happened? The flows, like shared flows, right, behave a certain way, right? So when you send an event to a shared flow, if there is no observer, the event is lost, right? You can add a replay, but that's not what you want on these kind of flows, because if you add a replay, right, that means that when a new collector joins, the last emitted value will be sent. So in case of a configuration change, like recreating the screen, that causes the view to unlink or stop collecting and start collecting back, you will get replayed, right? This can be circumvented a little bit by using state in, but it's not completely safe, because we can do also compose flows can be stop collecting on pause and all that. So in channels have a similar issues where the event can be lost, right? So the solution that Google came up with was using the state flow, right? And since we are already using a state flow for the state, right, we include that as a property in the state. So I think I didn't mention it before, so you can see it here. The view effect is of type null, right? And then, let me see, and then you see, so is this cell interface. So essentially, the consume effect, so when we the solution was, right, to put it on a state flow, because the value won't be lost, right? The state flow will hold the value, right, like forever until the flow is completed, right? So what happens, because a side effect are one-time events, right? I just want to consume it and forget it, like fire and forget. So essentially what we need to do is that when we consume the effect in the UI, we acknowledge that we are actually consumed it and let the view model know, hey, I consumed the last event, please clear it, right? So, and that's why we use this consume effect flow. So this is in the Android documentation. You can go there. But if you want to know more about the story of all this conversation, you can look for a Medium article by Manuel Vicente Vivo, which was Google. He used to work for the Compose team. He's no longer in Google, but he wrote that when he was in Google. And you can see in the comments, there is a link of a GitHub issue. You will see Elizarov from JetBrains, which he was one of the biggest heads in JetBrains. I said was because he left I think he quit, like he just went to some beach in the Caribbean and quit programming. So they had like a very long discussion on the best. They started. Manuel also like gave Colin like, hey, I give you this suggestion. Let's do that. But Google ended up coming up with this approach. I think I like it. I think it's safe and clean. And last but not least, we need to add the process event to process all the events that we get from the UI, right? So here, since this is a Okay, I need to go back. Okay, so here, since this is a seal interface, right? We can take advantage of that and use a when. So it will enforce that I need to, take in consideration every single case of that seal interface, right? So now here we can just receive the event and just do what we need to do in this case, right? So this is basically how we can integrate or how we can implement MVI using Android, right? And then now how we use this. So in the as we said before, we saw before, we can collect the view state flow, right, as a state with this function to make it safe with the life cycle. And then here I have my stateless screen composable. I pass the state, and I also pass a reference to the process event function of the view model, right? So, and essentially this is good because instead of having multiple callbacks for any kind of event that I have, imagine if I need to add a callback for every event. Like if I have a like event, if I have a reload event, if I have a comment event, I need to have all those callbacks, right? And that will be a mess, right? Because I need to pass all those callbacks between my composables. So the good thing about this approach is that I can only pass, one callback, and then whoever needs to send an event can decide what to send because I have a type that can be whatever. So in this case, I check that I'm passing the same callback just once, right? And then I can send. So this one, news card, have a button. They want to send like news, the like news event, send the ID, and just like that, you can do it. Instead of having 10 callbacks, Lambda callbacks, you can have only one and do it like this. Is cleaner. The sixth is related to this because if you noticed, I told you about state, event, and effects. So what happens with the effects? The next tip is about that. So create an effect handler. You remember what I said, that the composable should only do one thing? So it's not a good thing to also handle the effects in the same composable that you draw UI, right? So you can use a separate composable for that, which is the effect handler. And let's go back to our news list screen, right? We have this, what we left before. But now we need to collect our view effect. Remember that we got it from the view state one. So we essentially collect it. And so after using the flow operators, we end up with a call flow, right? That's why when we use the collect as a state with lifecycle, we need to provide a default value. So I'm providing null. And then we can build our effect handler. So I can receive the effect, right? It's a nullable, and the on event, right? In case I need to send another event right here, like the consume effect. So I check that the effect is not null, right? If it's null, I don't want to do anything. And using a when, since this is also a CL interface, I can use when and just do what I need to do, right? If I add a new item to the view effect, it will automatically make my code fail, right? Because I need to implement the other branch here, right? And for this, we are using this side effect, launched effect, that essentially launch a new coroutine that is restarted every time the key changes, right? So every time effect changes, this will run this code over here, right? So essentially, this complete the picture of the MVI implementation in Android. So when handling your effects, I recommend using a separate composable with that. That you will need to add it in your composable screen like this. Just add that and let that composable care about those effects. Leave your UI composable just for UI. And this is how you add a new effect. Like your state flow, you just update it, and the effect property, you just set it to whatever effect you want to send to the user. The 7th tip is use the stricter visibility modifier possible in your composable. Keep your composables private whenever possible, because when you are writing code, right, if you have all your composables public, you can have more suggestions that you may like, right, when you only are using that composable in some other screen. In case you need to use that composable in multiple files, but in the same module, please use internal. And if you need a composable, right, that you will have in a shared module that you will use in multiple feature modules, you can use public only for that case, right? The next one, well, is part of the same. The preview should always be private because you don't want to, when you're writing some code, a suggestion of a preview. You don't need that, right? The 8th tip is when using type safety for navigation compose, make all your routes inherit a common parent. And why? Like, this is a personal preference. I just wanted to share it with you. So we have this CL interface, DevFest Venezia route, right? And I have all my routes from my application. So you know that when using navigation compose, it uses any, right? But any can be whatever, right? I don't have, so we calling developers prefer type safety, right? We prefer to know what that is. So we can circumvent that. I'm sure the compose team will, get around that anytime soon. But while they do that, you can circumvent that by creating a CL interface and make all your routes extend from it. And what is the advantage other than type safety? That if you want to write some extension functions or whatever, instead of using any, right, that will take in consideration anything else in the application, you can use your type, right? And this will represent all your routes. So for instance, in the navigation compose, we have hash route that take a route, right, and let you know if that route is that other, if the nav destination, is that route, right? So I wrote an extension function to be able to check for multiple using a var arg, right? So then here I can specify my generic type to be my common parent of the routes instead of just T, inherit any or anything like that. And yeah, of course, in the view effect, instead of having route any, you can have route of your type. So this gives you, the code become clearer, essentially. The 9th tip is master the compose phases. Look, here I want to make a stop, especially for the Android developers with more experience. Or, this applies to all developers. Look, developers, when we learn how to develop, right, we kind of understand that we can develop for everything without reading the documentation. And developers are most of the time, many times, like reluctant to read documentation. I don't know why, because that makes you a better developer. And many Android developers see compose, right? And they say, okay, this is easy. I describe the UI. I have a state. That's easy. I can do it. But compose is more than that. And mastering the compose phases, know how compose works under the hood. It's very important for us to know how to write more performant code. Under the hood, compose uses a 3-phases process to convert data to UI, right? The first phase is composition. The second one is layout. and the third one is drawing, right? So composition essentially creates a tree representing the relationship between the composables. So imagine that we have a composable with the code like the one in the left, like we have a row. Inside of that row, we have an image and a column. And inside of that column, we have two text composables, right? So essentially, in the composition, oh, I think I pressed the wrong button. Okay. In the composition phase, we will build that tree saying, okay, we have a root composable row, which has two childs, right? And one of them has other two childs, right? So that's the first one. Then in the layout phase, takes that tree as an input and calculate the size and position of every composable, right? And we end up with some information like this. Like we know the size of everyone, and we know where is each composable placed. Then the last one is drawing. So this is easy. This is just the one that actually adds the pixels in the screen, right? So understanding that is very important. And the last tip is optimize state reads, which is related to understanding the compose phases. Phases can be skipped. So I told you that the compose is a three phase, right? First, composition creates the tree. Second, layout, the measurement and also position of every composable. And then drawing, that actually throws the pixel into the screen, right? But you can write code that skip composition and layout and only run drawing, or that skip composition and only run layout and only run layout and drawing, right? How can we do that? So before me, there was a talk about animations, right? Imagine that we are using this animation. Remember what I said, that when animating, the composable can be updated on every frame, so very frequently. So essentially, instead, so here's how it works, the animation. So I changed the color, right? So essentially, if I use the background modifier, right, I'm calling that on every frame. I'm setting the background, right, on every frame running, and those modifiers that are just function calls run in the composition phase, right? So this will run on we'll run every phase on every frame. But if I use a draw behind, there are a couple of functions that start with draw, or also another ones like canvas or stuff like that. You can look for it. If I use this one, this will only be executed on the drawing phase, right? So it is called on every frame, but it skips composition and layout. The next one, yeah, so you see it here. The next one is how do I skip the layout phase? So in this case, we are animating the position, right? So I want to skip the layout phase in that case. So I'm changing the offset modifier here, right? So if I use the offset function, that is a function call that runs also on the composition. But all these modifiers that are not draw something or canvas that runs with the lambda, these run on the layout phase, right? You can see it also in the documentation of these functions. So you can just use this to skip the composition phase. And in summary, first, composables should only do one thing. Avoid calculations in the composables. Make sure your composables and state classes are stable. Create a stateful and stateless overload of your screen composables. Enforce the unidirectional data flow, or UDF, with MVI. Create an effect handler composable. Use the stricter visibility modifier possible in your composable. Make all your navigation routes inherit a common pattern. Master the compose phases, and optimize state reads. So that's it. Anyone has any question? The guys understood everything or nothing? One of those. All right, so if there is no question, here's my LinkedIn and my blog. You can follow me. I love to talk about Compose. I love to talk about calling multi-platform. I'm an enthusiast, so if you want to talk about that or have any question, or Android in general, just you can hit me a message. Thank you, everyone.